In your work with inequalities so far, from 7th and 8th grade, an open dot is, if you have an inequality, is going to be a less than or a greater than symbol. So an open dot means that it does not include it in your answer. So if you had, for example, x is less than 4, you would make an open dot at 4. Whereas a closed dot means it includes the endpoint. So if you had a less than or equal to or greater than or equal to, then you'd put a closed dot at the 4 and shade either to the right or to the left. Continuous, a continuous situation means that can take on any value within the range. So it's a word problem that can take on any value in the range of numbers. So for example, a person's height could be any value. You could be 4.52, you could be 5.57 inches tall, or you could be 5.637 inches tall. It could be any value in a range. Or time, or weight, or length. Those are all examples of continuous, and we'll practice down below. A discrete data set can only take on certain values. So for example, the number of students in class, or the amount of money that you pay at the store if you're buying shirts that cost $12 each. There's no way you could buy something for $6 if the shirts cost $12 each. You could never have your total be $6. And a new thing that we're going to practice today is called interval notation. So interval notation is, and I'll show you examples down below, and we're graphing these, but when you use interval notation, we're going to use interval notation for continuous situations. And if you have a bracket, it means it includes the endpoint. Whereas you have a parentheses, it means it doesn't include the endpoint. So if I had this number right here, 4, a closed dot at 4 shaded to the right, and I want to use interval notation, inequality notation would look like this. X is at least 4, x is greater than or equal to 4. But interval notation looks like this. So what you want to do is on your number line, what's the least number that you start with? Well, it starts at 4, and it includes 4. So I'm going to put a bracket at 4. And when does it stop? Well, it keeps going. So if it keeps going, it's going to infinity. So infinity symbol looks like this. It's kind of a sideways 8. And because infinity is not a number that we can actually put a stop on or mark, we actually use a parentheses for that. Now I'm going to do another inequality. This will be an open dot at 4 going this way. So if I use interval notation to describe that, if I'm starting to the left, well, all of these numbers are included all the way over here, and it never stops over here. So it's actually starting at negative infinity. You always want to start from left to right, comma, and then it stops at 4 and does not include 4. So that's going to be an open circle. So we're going to practice interval notation with the continuous data. So here we're going to have word situations, graph them, and figure out if it's continuous or discrete. So the golf team will finish their match within 3 hours. So within means that it could be 3 hours. So it's 3 hours or less. So I can write it as x is less than or equal to 3. Or I could switch and write the variable on the right and put x right here, 3 right here, and the variable and my inequality symbol is going to change. So I want you to be able to comfortably go back and forth with these two. So either case, 3 is greater than or equal to x, or x is less than or equal to 3. So before I graph it, I really should think about if this is continuous or discrete. So since we're talking about time, You could finish in 2 hours and 56 minutes, 2 hours and 57 minutes. It comes up with a whole range of values. So I'm going to make a closed dot at 3 and shade to the left. That's less than or equal to 3. And it's continuous. And I'm going to write this in interval notation, which is it's starting at negative infinity. So I put a parentheses, negative infinity, comma, and it ends at 3, and it includes 3. Okay, second one, Max will try no more than 4 new tricks. So, no more than means less than or equal to. So, the same way, 4 is greater than or equal to x, or x is less than or equal to 4. So it includes 4, so I'm going to put a closed dot at 4. Before I graph it, I got to figure out if it's continuous or discrete. So the graphs are different. So continuous. Can he try 3.2 more tricks? Can he try 1.5 more tricks? No, he can't. So it's actually discrete because they take on certain values. So when you graph it, you need to make sure that you put dots. So discrete means you're putting dots for the tricks that you can try. So 3, 2, 1, 0. So you're putting dots on the actual data points that can be included. And I'm not going to use interval notation since we're talking about discrete data. And the missed tackles better not exceed. Not exceed. So exceed, it can't go past. So that's going to be another less than or equal to. So then before I graph it, I got to think if it's discrete or continuous. So discrete means certain values. So you got to think about, can you have part of a tackle? So can you have 1.375 tackles? Can you have 2.782 tackles? Because it has to be everything in between. You can't. So it's discrete. So I'm going to use dots. 2, 1, 0. And then next one, Heather will miss at most 10 homework assignments. So at most, we have another less than or equal to situation. This is also going to be discrete because the number of homework assignment you miss cannot be decimals. So I'm going to start with 10 and go down 9, 8, etc. Scott will run faster than 7-minute miles. This one's kind of tricky because faster when you're running is actually less than. And we're saying faster than 7-minute miles, so he has to run less than a 7-minute mile. So this is not including, and it's actually going to be continuous because it's time, because you could run different seconds involved in a less than 7-minute mile. So it's going to be an open dot at 7. It's going to be continuous. It's going to be shaded to the left. So I can write interval notation. It's starting at negative infinity, stopping at 7, and not including 7, so I put a parentheses. Next one, the quarterback will have no fewer than. So no fewer than means no less than. So we have to have, the quarterback will have no fewer than. So it says 2. So greater than or equal to 2. Or 2 is less than or equal to x. So this one's going to be discrete because your interceptions aren't going to come in decimals. So I put a 2, closed dot, closed dot, closed dot. That means discrete. That means we're not having parts of a tackle. The team scored with less than 42 seconds left in the game. So x is less than 42, or 42 is greater than x. So on the graph, it's discrete or continuous. It's going to be continuous because you're talking about time and you can have parts of time. So this is 42 as an open dot and you're shading to the right. So interval notation is the graph starts from left to right at 42 but does not include 42 and it keeps going all the way to infinity. She has fewer than 5 pairs of shoes, so it's fewer than. So x is less than 5. It doesn't include 5. Or 5 is greater than x. We're talking about shoes, so it's going to be discrete because we can't have parts of a shoe. And we're not going to make it closed out at 5 because it doesn't include 5. So we're going to put 4, 3, 2. You can put an open dot at 5. He has more than $7 in his pocket. So you can have decimals for cents in your pocket. So more than $7 or 7 is less than x. It's going to be continuous because you can have parts of a dollar in your pocket. It's going to be an open circle because it doesn't include 7. Shaded to the right. And then in notation, the least number it starts with is 7. And it doesn't include 7 and it goes to infinity. And the second part, come up with 2 numbers that will satisfy each equation. So we got to think of 2 numbers that we plug in for x would work. So inequalities, you're going to have an infinite number of solutions. So what's a number that you could plug in for x that could work? You could plug in 0 because the opposite of 0 plus 2 is less than 5. You can plug in 1. B, what number that when you divide by 4 you're going to get greater than 8? If I plug in 10 divided by 4, I mean, not 10, but I meant if you plug in 40, because you'll get 10, or 60, because you get something that's greater than or equal to 8. And the last one, what number, when I subtract 3 from it, is going to be give me greater than or equal to or 9? So I'm going to plug in, you could plug in 12, because 12 minus 3 is greater than or equal to 9. Or you could plug in 20, because 17 is greater than or equal to 9.